Welcome to Computer Tech and More. Today we're going to take a look at the TL-C12. This is part of my redone series where I redid my whole noise testing analysis. Let's get right into some information. First, what is this video series actually about? Well, I redid all my noise testing analysis for every single fan that I've tested up to this point, and it's going to be the new test methodology going forward. I've got a short little video on my channel as to the new test methodology. But long story short, the previous testing methodology, I had the microphone too close to the fans and I was getting extra interference that was creating artificial artifacts. Now the testing isn't invalid, it's just for a set of circumstances that weren't specifically for what I wanted. Basically, with the previous test methodology, it was acting like a mesh filter directly over the fan, or having the fan in a pole configuration in a fin stack, with the blades interacting with the fin stack, creating extra noise reverberation. That is not the kind of testing I actually want to pick up. I wanted it to be more of an open airflow environment, more like modern cases where the mesh filters are a little bit spaced away from the fans. So also the improvement from the previous test methodology to the new one, previous one had an accuracy overall of plus or minus 4 decibels. That is an 8 decibel range. And as you may or may not know, every 10 decibels is a doubling in noise volume. And the new testing methodology is accurate within plus or minus 2 decibels, so that is a 4 decibel range, thus further increasing it. And I'm doing that by picking specific times and noise levels within the house that are within a specific range to improve the consistency. Unfortunately, this is the maximum that I can get with my current testing setup. For future testing, I can't do without help from the community, i.e. viewers like you subscribing to this channel so that YouTube will start paying me. Joining me on Patreon, that would go a long way in helping me progress even faster, because I want to buy the next level of equipment. I would like to buy a new dedicated microphone specifically designed for noise testing as opposed to the one I'm using for my voice. The one I'm using right now is great for getting a decibel reading, but not as good for checking the spectrum for how the fan's readings are. I'd like to upgrade my testing box, so make it out of sturdier materials so that it acts more like a real box. Build a little sound chamber. It won't be like Gamers Nexus or Linus Tech Tips are building, but just a small little box to block out some residual noise to get myself the noise floor in that box that I'll find acceptable. I want to get a more accurate anemometer, something that is accurate within plus or minus 0.1 meter per second, as opposed to my current one that is accurate to within plus or minus 0.1 meter per second. Unfortunately, all of this does add up to a significant cost to me of like around $2,000 for everything that I would have planned, which is why I would ask, hey, do you mind helping me out on Patreon? I know it's a hard ask. I'm a small channel. I'll keep doing what I'm doing with what I've got, and if I ever get there, I'll go back through and retest everything with a new testing methodology. All right. And if you're new to this channel, I do recommend that you watch the second half of this video where I go into each of the tests, the specifics in it, and how the fans performed, why they're important, and other relevant detailed information. If you're returning to this channel and returning to these videos, you could just watch this overview part and be one and done, because I will have the original testing methodology on the right side and the new testing methodology on the left side, the ranking of the fan, where it positions with respect to the other fans that I've tested, the model number, the RPM it was spinning, and the airspeed it achieved. And for 100% pedal fan signaling, it will have the noise level listed as well. And I've got a change in my Norse normalized value. It is still based off the A12X25, spinning at approximately 1,400 RPM, just rounding to get me at a round decibel reading. So originally it was 40 decibels, now it's at 12 decibels for the same given RPM range. So with all of that said, let's go through this. First up for the specific tests is my case simulation test. This test can be looked at in a couple of key different ways, but the first one, and realistically the most important one for you, is how does this fan perform in whatever case size I plan on buying? Well, if you're looking at a full tower big case, the 14.5 inch mark is going to be your key data piece of information. It is representative of large towers, something like the Proctor Design Torrent. Next, we have the 11 inch mark. The 11 inch mark is representative of your standard mid-tower cases, something like the Corsair 500, 5000 series, and like the Fractal Meshify 2Cs fit into this category, and other standard mid-towers. The 9 inch mark is representative of compact towers. I don't have any specific models, but I would say something along the lines of like a Della Optiplex, basically a case that is pretty much the length of your motherboard, maybe slightly longer, but you're not going to be fitting a graphics card in there that is longer than a standard ATX motherboard, is what I consider the 9 inch mark. And the 6 inch mark is a small form factor case, not an ultra compact one, a small form factor that is still a front to back airflow, so it'd be ITX with a front to back airflow, not the ultra compact ones like the Fractal North, I believe it is, or Terra, where it sucks in air from the sides and blows it out the top, or the ones that suck in air from the bottom and blow it out the top. Those cases are actually going to be need pressure oriented fans, so I'd look at the data for how the fans performed on a CPU or a cooler. Mark is also representative of a short throw distance. By that I mean if you attach fans to the bottom of your case to blow into your GPU, blow air up into it, that would be representative of that 6 inch mark. But we need to compare against something else. So this is where this graph comes in, and I have my control fan. The control fan is my baseline fan of what I consider anything to be around it or above it to be a good fan. It is 3 parts A12-H5 to 1 part A14. 2 very good fans in their respective categories. I generally found that 140mm class fans tend to do better at the 11 and 14.5 inch mark, while smaller 120mm class fans tended to do better at the 6 and 9 inch data points. So blending the 2 fans together, I got not quite a perfect, but what I consider to be a good composite fan. So right away we can see that the TL-C12 is outperforming my control fan ever so slightly at the 6 and 9, and then is slightly underperforming at the 11 and 14.5, while the Pro is actually doing quite a bit worse. At 100% PWM fan signaling, the Pro is outperforming the Control and the regular C12, though not by too large a margin, but there isn't also that much RPM difference between the Pro and the regular, so you have to take everything into account. What is impressive is they got the same noise level. And it's matching my control fan fairly closely, indicating that it is a pretty good fan, and even the regular C12 is also a pretty good fan. Now, how do they compare against every other fan? Well, this isn't quite every other fan, but I have a large grouping of what I consider to be good fans, and then one fan down here that I consider to be a bad fan. What you want to be is far away from what down here what I consider this bad fan. Now, you might be looking at this yellow line going, well, that looks pretty low, but look at where it ends up at the 14.5 inch mark. That is why the Wonder Snail I still consider a very good fan, because it has a very flat drop-off, meaning it's good at concentrating its airflow and is a stellar design, especially for larger cases. Now for smaller ones, it's not ideal, so you can't pick and choose and win everything. But it's what I consider the bottom end of the good fans. So the C12Pro starts off right at the bottom end of the good at the 6 inch mark, and then drops off pretty steeply and ends up actually as an okay performer, like C category, while down here is like F. So it's like C category, while the regular C12 starts off A, drops down, drops down, drops down, ends up at about like, C+. So depending on what size case you're getting, they could be considered quite good or look somewhere else. How about at 100% PWM fan signaling? So the fan names are over here, the RPM, and as well as the noise value they generated. So at 100%, the C12, which is this orange line, it starts off as a middle performer and then drops to a bottom performer of the good fans. So I'd put it in that C category. The Pro starts off in a very good category, and then by the 9 inch mark, it's at a mid-level good, so probably like a B plus-ish. And then it continues to drop, and then ends up in like that C+ category. So again, depending on what size case you're getting, they're excellent to mediocre. How about their noise efficiency? So the 9-inch mark I want to talk about. So if you're looking at the key at the top, so it's airspeed versus decibels at the 9-inch mark. So, okay, all of that said, here's the C12. If you're wondering about this little joggle, it's where I hit a harmonic frequency within the fan. And you can see that it has gains efficiency, and then it actually flatlines pretty bad. It gets a whole lot noisier without pushing very much more air. So we're going to need to pay attention to that. So that's a little bit of a disappointing result for the regular C12. The Pro, on the other hand, has the smooth climb, and it doesn't have that little joggle. So it could be that it just happens at wherever this RPM range is exactly. And because of PWM fan signaling, the C12 Pro, I just skipped past it. I need to do much more extensive testing to verify that. But it climbs and climbs and climbs and climbs and climbs. So why it does this, don't know specifically, because the two fans look fundamentally the same. In terms of their positioning, well, you can see it with comparison to other fans. The Pro is at the bottom end of the quote-unquote good fans. The C12 starts off actually pretty good, and then, I didn't mean to click. And then it actually becomes a pretty poor performer. Mind, it isn't the worst, but a pretty poor performer overall. To airspeed through my CPU air cooler. My cooler is the Noctua U12A. It's a larger single tower cooler. The left graph here is RPM versus airspeed. Airspeed is vertical, RPM is horizontal, and on both these graphs, better fans are top left, worse fans are bottom right. And on the left graph, RPM versus airspeed is basically fundamentally a blade efficiency graph. It is how much air is this blade design able to push at a given RPM. So if you watch the channel like the Fan Showdown, you could compile this information and make the ultimate best blade design ever at pushing air. In theory, at least. It's a lot of experimenting. And you can see that the two fans are actually pretty efficient at pushing air. They're beating out my control fan. But on the right side, we have noise versus airspeed. So that's how noisy they are for the given airspeed. Well, the C12 actually lines up fairly well with my control fan, while the Pro starts off better, like the regular C12, but then gets significantly noisier for a little bit and then kind of levels out. And one concerning remark with the regular C12 is right here from this data point to here. So where it goes from like 1,400 to 1,500 RPM, where it basically just doesn't get any more airspeed but becomes significantly noisier. That leads me to believe that there's another harmonic in the fan blade around that, or around that point, that isn't being picked up over here. Anyways, how do these fans compare against each other? First, a little bit of explanation. So I did a series of tests on my CPU or cooler for letting it run a CPU-only load, letting it go to thermal max, taking a reading of the airspeed going through the cooler. We've seen what the wattage was for that steady state environment, and then dropping the PWM fan signal, letting it equalize again, getting the airspeed, and taking on the wattage and dropping it down, so on and so forth. So thus, I was able to get a wattage per airspeed, or airspeed per wattage ratio. And it is an estimation. There's a little bit of leeway in it. It's accurate within about plus or minus 5 watts. So it's not that dramatic. You're not going to gain that much extra clock speed for 5 watts at the upper end. At the lower end, it matters a bit more, and that's actually where it's more accurate. Anyways, my CPU is the i7-11700K, and of course we know what kind of cooler I have. So if you don't have the same CPU as me, but the same cooler, this data may not be directly applicable. And if you don't have the same cooler as me, it won't be directly applicable. So then how can you use this data? Well, let's say you have the NF-P12 Redux. It's moving 0.7 meters per second at my noise normalized value of 12 decibels. Well, if you upgrade to the C12, you're going to be pushing 1.2 meters per second of air. So thus, for the same noise level, you're going to be able to push a higher wattage for an unlocked CPU. If your CPU is locked, your CPU is going to run cooler with that higher air velocity, or you can take this extra overhead, pull down your PWM fan signal a little bit, and now your system will run a little bit quieter. So that is just how you can use this data. And the Pro is sitting kind of bottom middle overall compared to the other fans. It's not a bad place for it to be, and it's sitting right in line with like the TL-G12, the Storm 120, and several other fans. But the C12 is actually, the regular C12 is actually outperforming a little bit and is in a pretty good position too. At 100% PWM fan signaling, we got the same wattage to airspeed ratio. The regular C12 is towards the bottom of the graph because of its limited RPM range, but it is sitting right in line with other 1,500 RPM fans that I have tested. The TL-C12Pro, spinning at 1,900 RPM, is actually sitting above many other fans in its RPM class. Mind, the ones that are just 100 RPM higher than it tend to outperform it a little bit better, but it's overall actually a pretty good position for it. I mean, I find 2 meters per second to be plenty acceptable considering that the A12X25 pushes 1.9 meters per second of air. Now, one thing to pay attention to is noise level. The Pro is at 24 decibels, the regular C12 is 24 decibels, so they are on the noisy side for their amount of airflow. For example, the A12X25 is only at 19.6 decibels. Next, this is airspeed through the cooler versus decibel rating. And on here are what I consider to be good fans. And you can see that they line up fairly well. The C12 Pro is actually at the bottom end of the good fans, so you can't win everything. The regular C12 actually does fairly well. I mean, it flatlines a little bit, and then it hits a harmonic, and then it bounces back up, and then gains a lot of performance, and then this must be just another harmonic that's hitting right there, and just becomes really noisy. So they have like a C12 Max that I like to get a hold of, but it's like a Japanese only fan. So now we're on to CFM testing. So I'm not a huge fan of CFM testing under a lot of how a lot of other reviewers use it. A lot of other reviewers use CFM testing to measure case airflow, to say, yes, this fan is going to be good inside your case because it has this CFM value. The reason that it's not good for measuring case airflow is, you stick this fan, it's the same diameter as the tube. There is no room for this air to spread out. So that means all the air is going to travel down the tube. The case simulation test is what actually everybody should be doing, or a test similar to it. I actually want to do a number of upgrades to my CFM testing. That's another thing. I want to get this cone shape and have it be the same size as a 180 millimeter class fan, so that I can do 180s down to 120s, and then get a second set of cone that is 120 down to, that can do 120 down to like 80 millimeter, 60 millimeter class fans, so that I can have like 120s as like the de facto mid-ground and be able to test this wide variety of fans, and then upgrade my overall testing for CFM testing with a longer tube. So that's what I'd like to be able to do with it. And that would be a better middle ground for actually like letting airflow spread out, not giving you the false positives. Now, CFM testing can be used in other scenarios. Here are the fan's PQ curves. So PQ curves are just, you have a pressure sensor, you have a slit opening or something like that here in the middle. You would measure static pressure, dynamic pressure, you'd have the airspeed coming out the back, and you get all sorts of readings as to how it does in a variety of pressure scenarios, generating those PQ curves that Noctua and other fan designs like to show off. Unfortunately, that still doesn't take into account how the airflow actually spreads out or not, but it is a vital piece of information for how a fan handles different types of pressure scenarios. So again, depending on how CFM testing is used, it is perfectly valid, but how a lot of other channels, like Hardware Canucks, uses it is completely invalid. Their heatsink testing, though, is great. So I'm going to go through these fairly quickly in both these graphs, just like the air cooler ones. Left side upper is better, right side lower is worse. And sorry, I'm with the hiccups right now. My control fan is blue, and the fans are all in basically a perfect line. And this is like case in point. If you look at my testing in general, they all pretty much flatten out and are a straight line. So it's like case and point. This testing doesn't work for case simulation, but does do heatsink testing. Next, we have the noise level, and it's fairly similar to the previous one where it's got the little joggles, and the regular C12 just kind of flat lines. While the regular C12 Pro climbs and climbs, but it's got a far larger deviation away from my control fan, which isn't great for it to have. So now how do they compare against other fans? Well, at noise normalized values, the C12 is actually in the upper part of the graph in a great position overall for it to be, but it's still a far cry from the best. The C12 Pro, on the other hand, is a little bit lower. Let's keep moving on. At 100% PWM fan signaling, the Pro is kind of the bottom, and the C12 is toward the bottom. Actually, it's doing about where it should with the other 1,500 RPM class fans. Now, their efficiency, so this is CFM per decibel. And we have the other good fans on here. They're doing okay at lower RPMs, lower airspeeds, but as things climb to higher airspeeds, they just become worse and worse and worse. So now we're on to the value proposition. First up, the C12 is a $10 fan, and the C12 Pro is a $12 fan. So they're very close in price. They're fairly close in performance, but $2 at their actual performance level is a very significant amount in the value proposition. So these graphs are performance per dollar. So if you're on an ultra tight budget, you want to get the best bang for your buck, so value proposition is the most important thing for you. If, however, you have a little bit of extra money to spend and you want to get a particular aesthetic, you want to get some RGB, you want to have a little bit better noise performance, you want a little bit higher performance overall, that's where you'd weigh this data against the other data and determine which fan best suits your particular needs. And note, in this video, I don't have every fan that I've tested, so you may need to check back on my channel with the redone series and pick out a fan that works best for you. Where was I? Oh, on the right side we have, or the left side, we have noise normalized values. On the right side, we have 100% PWM fan signaling. And the C12 and the C12 Pro do fit in the upper part of the graphs. They're both excellent performers, but they're far cry from the best performer, which is the TL-G12. And at the 11-inch mark to 100%, they once again are still right up towards the top, so they're definitely excellent value picks. Going through the CPU air cooler, the C12 Pro and the C12 are right up there at the top, once again, in noise normalized values for their value, making them an excellent choice overall. At 100% PWM fan signaling, they are still right up there towards the top, but they're not quite as close to the top performers, and they're sort of in the middle of the value proposition there, but still overall a great result for these two fans. For CFM testing, noise normalized and 100% PWM fan signaling, they once again are ranked towards the top. At 100%, they're not quite as highly ranked, but still in excellent position overall. So where does that leave me with these fans? Well, their noise performance is pretty terrible, to be honest. Like, I'm going to tell you straight up. When and how you spend your money, that is your prerogative. I'm presenting the data, and then right here I'm just giving you my general opinion. So if you need a cheap fan that is a good performer, they definitely aren't a bad pick. In certain scenarios, they do outperform the TL-G12, but if you're on an ultra-tight budget, the G12 is just the fan to pick. One thing I haven't gone into is longevity testing. It is currently outside my purview, my capability to test. It is another thing that I'd like to add into my testing, but I can't do without help from viewers like you, because there's more to it than just hooking up fans. I need to get the equipment to be able to run these fans for long periods of time. So I'm a little bit stuck in my current situation with where I can go with this channel. So if you like what I'm doing, please subscribe. Let's wrap things up to the next section. So at the end of every video, I like to show off my raw data. Here it is for the C12 and the C12 Pro. It's right there. So this data does belong to me. However, if you're going to use it for your own personal use, as in you're going to put it into your own Excel template or worksheet so that you can basically have all my data so you can compare fans for your own purposes without needing to go back to my videos every single time, you are more than welcome to do so. However, if you're going to use it in any sort of publication that's written, journal, or a video, I do ask that you reference me and my channel. I'm the one who generated this data. and it takes me a lot of work to do it. This level of granularity in testing does take me around 1.5 to 2 hours to do per fan. Then it's a lot extra work to do updating the Excel and upgrading the graphs, making the presentation in PowerPoint, and then, of course, presenting the data. So it is a bunch of extra work in there, where otherwise I could just collect this data for myself. So if you do want to use it, I just ask that you reference me because, hey, that's the proper thing to do, and I've asked you to do it. Other than that, if you've got suggestions for more fans for me to take a look at in the future, please leave in the comment sections down below. If you've got suggestions on how I can improve my videos, please leave those in the comment sections down below. I do take all of that very seriously and try to implement the improvements over time. Just note that it may take a little while for improvements to be seen because I tend to buy a lot of fans and then retest them. And during the redone series, I am basically in the process of filming all of them right now. And then we'll be releasing each of the fan videos over a course of a period of months. So all of that said, thank you very much for watching my video. I hope you enjoyed it. Please subscribe for more content, and I really appreciate if you all join me on Patreon. It'll really help me with this channel and being able to acquire the better testing equipment. Otherwise, have a great day, great evening, whatever time zone you're watching this in. And I'll see you next time here on Computer Tech and More.